Good morning and welcome to the K webinar Wednesday. Today we're looking at Plug into the Future, electrical vehicle charging and Part S with Sam Lott. This webinar will be discussing the importance of electrical vehicles and its part to play in the UK's net zero goal by 2050. We will discuss the different types of electrical vehicle and focus on the electrical vehicle charge points in the home and how they work. We'll then go into detail regarding the implementation of Part S in June 2022. Which regards the infrastructure for the charge of electrical vehicles and how this impacts housing developers and housing associations. My name is Shanika and I'm the Training and Learning Administrator here at CABE, and I'll be acting as moderator for this morning session. We strive to create interactive webinars and we do encourage you to submit any questions you may have during the session. These questions will be addressed at the end of the presentation. We will get through as many as possible, but if we do run out of time, we will collect any questions and send out the answers to these in due course. You can also contact webinars@cbuilde.com. If you're watching us live, you can use the side panel to send in your questions. Alternatively, you can get in touch with us via the social links now on screen. Let me introduce today's webinar speaker, Sam Lott. Sam is an energy data consultant at Sava. His job is to work with customers to advise on their quality of housing, stock data, and give advice on different ways in which they can work towards their zero carbon goals. He's working on broadening consultancy services, the focus on sustainability, and has a keen interest into how he can best advise his clients on retrofitting, sustainable, and the importance of electrification in house sector. Before joining Sava, Sam completed a degree in biological sciences, followed by a Master of Research in biological science. So if you give me a couple of seconds, I'll just hand over to Sam and he will begin shortly. So Sam, you can go ahead.
Okay, let me just share my screen. Okay, there we go. So, hello there everyone, and thank you for joining us today. My name is Sam Lott. I'm an energy data consultant at Sava, and I'll be presenting the webinar today titled Plugging into the Future, an Introduction to Electric Vehicle Charge Points and Part S. So to just introduce who Sava are, we have two sides to our business, an education side and a tech side. The tech side provides support to housing providers with their energy analysis, helping over 240 housing providers customers with the provision of our software product, Intelligent Energy. We help report on over 4 million properties each year and integrate directly with major asset management systems. On top of this, we also have a Sava Analytics team, which provide consultancy support. The education side of Sava offer a variety of training opportunities with a range of qualifications and training modules on offer. One of the courses on offer is the Level 6 Diploma in Residential Surveying and Valuation, which offers direct entry into RICS and CAPE. We also offer online training modules on specific topics such as damp and condensation, etc. And more recently, we have begun to offer domestic energy assessor training, which you can find on our website. So now I've said a little on who we are at Sava, let's begin with the webinar today, which will focus on the current context behind the relevance of electric vehicles and generally how to use them and charge them. We will explore the current policies in place, which has contributed to the increase in the uptake of electric vehicles. And then we will specifically look into Part S, the new building regulation enforced in June 2022. I will then finish by exploring the future of electric charging and how further technological advancements may affect the industry further in the future. To provide some background to our discussion on EV charge points, it is important to understand the larger context. The UK is undergoing a gradual transition towards an electricity-based energy infrastructure. This shift aims to enhance the security of our energy supply while also offering greater flexibility for the future. The primary objective is to progressively reduce carbon emissions in the country by decarbonising the power grid, aligning with the UK's environmental goals. The government has expressed its expectation is that electricity will eventually power and heat our homes, vehicles and industries. This is in order to meet the UK's goals of becoming completely net zero by 2050. Road transport accounts for 25% of the UK's emissions, and the implementation of the new building regulations in Part S should help to reduce this. Part S will be a part of several new building regulations aiming to help decarbonise the UK. In the UK, it is estimated that only 2 to 3% of cars on the road are currently electric or hybrid. In 2022, 267,203 new electric cars were registered in the UK. The graphs on the right here show us that the number of electric cars on the market is progressively increasing year on year. Even with halts in production due to COVID and other production issues, we've seen this figure rise. This will only rise further in the coming years. A study conducted by Drive Electric, which is one of the leading electric vehicle leasing companies, has estimated that 448,000 new electric vehicles will be registered in 2023, making the total market hit almost 1.8 million in cumulative figures. Figures obtained so far this year show that electric and plug-in hybrid vehicles are representing a higher proportion than ever, representing 27.8% of all new cars on the road. Current policy dictates a phasing out of petrol and diesel cars from our roads. In 2017, the government announced a set of regulations to phase out petrol and diesel cars completely. These rules state from 2030, no new car or van may be sold which is fueled wholly by petrol or diesel. This then extends to banning new hybrid vehicles post-2035. We're also seeing regulations crop up across regions in the UK, such as the ULEZ zone, which has caused a nudge towards higher electric vehicle uptake in recent years. In order to meet the future demands for EVs, we will need the means to charge our vehicles. It is being estimated that the UK needs 4.1 million charge points by 2030, including home charge points, from a figure of just 182,000 in 2019. Part S aims to ensure the increase in charge point installations to meet this figure. The chart here at the bottom shows the number of public UK charging points and categorized them by speed. Between 2016 and 2021, the charge point network grew fourfold, from 6,500 to more than 28,000 devices. And between 2020 and 2022, we saw this rise from a figure of 28,500 to 37,000. With Part S being implemented and a higher adoption of electric vehicles, these figures are expected to rise rapidly. So to give some background information and explain through some of the confusing terminology that exists surrounding electric vehicles, let's begin by exploring the different types of electric vehicles that are around. The very term electric vehicle can be confusing, as generally it includes both fully electric vehicles and various types of hybrid vehicle. Firstly, we have fully electric vehicles which operate under electrical power at all times. They must have their batteries charged by plugging into mains electricity in order to function and replenish their charge. We then have plug-in hybrids, which can be plugged into mains in order to charge batteries, which are designed to provide the majority of the vehicle's power. However, they also have a small petrol or diesel engine that is usually only used as a supplement in times of running out of charge, etc. There are then full hybrids and mild hybrids, which do not have a way to charge the battery via mains, and they use their petrol or diesel engine to drive the vehicle. By 2035, any new car on the market will need to be fully electric. The EU has also gone with this line, stating that from 2035, all new cars will have to be zero-emission vehicles. If the direction of travel is that we will all be driving electric cars, then it is important that we all understand how to charge. Gone will be the days of just filling up at the petrol station. There are multiple ways that you are able to charge your vehicle, with varied speed and function. Firstly, there is your portable charger, sometimes referred to as a granny cable, which comes standard with most cars. This is a cable with an electric vehicle service equipment unit termed EVSE attached to the cable. The big benefit of these cables is that they are portable, meaning you can keep it in your vehicle and charge when you visit relatives or friends, for example, hence the nickname granny cable. This allows for a quick top-up in charge to your EV before heading home, as they can plug straight into a traditional 13-amp socket. These are, however, very slow and would take a considerable amount of time to fully charge a vehicle. Then we move on to designated charge points, which require a specific charging cable that plugs directly into your car from the charge point. The first type are the standard charge points, which are now considered slightly old and less seen, with relatively low power of 3.6 kilowatts. We then move on to what have been termed fast charge points, which are almost double the power of the standard charge points at 7 kilowatts. These are now going to become the minimum standard for installation under Part S regulations. And then lastly, we move on to rapid charge points, which have much higher speeds, with some reaching as high as 350 kilowatts. To put into context how power will impact the charge times of vehicles, a 40 kilowatt hour car battery seen in a Nissan Leaf, for example, can be charged to 50% in just 20 minutes with a 50 kilowatt rapid charge point. Whereas with the older standard charge points, it would take over 5 hours. These rapid charge points have started to become much more frequent in the last few years. Most Shell garages have their own Shell rapid charge points, and you often see Tesla superchargers at service stations along with other brands such as GridServe and Ionity. Different types of cables are needed for differing speeds of charge. The first type of connecting cable is called Type 1, which consists of 5-pin connectors typically found in older electric vehicles. These cables are limited to a maximum charging capacity of 7.4 kilowatts and are not commonly used or seen today. We then have Type 2 connectors, which utilize 7-pin connectors and are currently the most common type in Europe. These cables allow for higher charging power, reaching up to 43 kilowatts. In the image on the right, you can also see a CCS connector, which is essentially a modified version of the Type 2 connector. CCS connectors have 2 additional power contacts that enable direct DC charging, facilitating rapid charging. In the bottom right illustration is an explanation of the different types of charging. So batteries operate on direct current, while the power grid delivers alternating current. Therefore, a conversion is required for charging batteries. In the slower charging points, this conversion happens within the vehicle itself, as can be seen in the top half of this image. However, in rapid charging, the conversion has already occurred, allowing for direct DC-DC charging. The CCS connector is what facilitates this direct DC charging. Using information from the previous 2 slides, I'll now discuss briefly the 4 different modes of charging, which is important to understand before mentioning Part S. Mode 1 charging is now no longer allowed as it is deemed unsafe for use. It worked by connecting a cable to a traditional household outlet to charge a car. Mode 2 charging is essentially the same, however, it incorporates an EVSE unit and specific integrated shock protection cables. Mode 3 charging then involves the use of a dedicated EV charge point unit, where the EVSE is incorporated into the charge point and allows wider range of charging. And then lastly, there is mode 4 charging, which is, as discussed before, allows for direct DC charging with power capable of being well over 150 kilowatts. To charge at home, you may need to be able to connect to a charge point unless you use the granny cable, which is very slow. You may be wondering how much charge points actually cost. Well, the RAC estimate that the average home charge points cost around £800. On this slide, I've put in a few examples that are currently on the market. On the left is a pod point charger. In the middle, we have an Ohm ePod. And then lastly, on the right, we have a more expensive option called the Anderson A2 unit, which costs upwards of £1,500. But it does show that installers are trying to make the designs of charge points more aesthetically pleasing. All 3 of these units displayed are untethered. This simply means that no cable is permanently fixed to the device, and instead you would use your traditional portable cable to plug into the EV charging unit. I'll discuss this more later. So now we have spoken about electric vehicles and charge points and given a bit of background information. I will now specifically begin discussing Part S. Part S is a new building regulation titled Infrastructure for the Charging of Electric Vehicles and was brought into force on the 15th of June 2022. I will discuss what it entails, who it impacts, and any exemptions or transitional provisions that it entails. Part S will apply specifically to the following types of construction: new residential buildings, including individual properties, new non-residential buildings, such as retail or office spaces, buildings undergoing a material change of use, such as retail spaces turning into flats, etc. Then there are also buildings that are undergoing major renovations. To clarify the term major renovations here, this will not impact individual households renovating or doing extensions. This is focused on renovations which result in more than 10 associated parking spaces. So more like renovations which result in large houses being turned into flats. It also requires more than 25% surface area of the building to be undergoing renovation. And then lastly, mixed use buildings that fit any of these criteria would also need to follow Part S. So let's begin with the technical requirements for electric vehicle charge points brought in under Part S. Part S now dictates a minimum 7 kilowatt nominal rated output. It requires it to be fitted with a universal socket, also termed untethered. It does, however, state in exceptional circumstances, such as instances of self-build, you may be allowed to install tethered units. Units must also be installed with indicators that let the user know the equipment's charging status using lights or a visual display. A key point here is that they must have smart capabilities. This allows the charger to be controlled via smart apps on your phone, etc., so you can alter the charging speed and monitor its charging. This allows users to make use of cheaper tariffs that promote charging during low grid demand periods, essentially saving them money on charging and also helping reduce grid-side demand. Part S also indicates charge points must be a minimum of mode 3 or equivalent and must meet the requirements in the IET's Code of Practice. Regarding new residential buildings, Part S mandates the installation of EV charge points in proximity to parking spaces adjacent to homes. In cases where parking is shared, if the number of spaces is equal to or fewer than the number of dwellings, all spaces must have EV charging points. If the number of spaces exceeds the number of dwellings, the number of EV charging points must match the number of dwellings. As mentioned before, these charge points must meet new technical requirements. The top right image here illustrates the recommended setup, also referred to as Mode 3 charging, which was discussed earlier and is now a requirement. Another significant requirement under Part S is that all charge points must be untethered, meaning they should feature a universal connector that allows any vehicle's charging cable to be plugged in. This approach prevents car manufacturers from monopolizing the market and necessitating specific charging arrangements, akin to what we observe with phone chargers. Charge points also must comply with regulations such as Part M and the Equality Act 2010 to ensure accessibility for all sections of the population. Part S requirements are not limited to new homes with off-street parking. They also extend to parking spaces provided in multi-residential and mixed-use buildings. For residential use, associated parking spaces must adhere to requirement S1 in Part S. This stipulates that there must be at least one EV charger per household, rather than requiring every parking space to have a charger. However, provisions should be made for future connection locations for each parking space that doesn't have a charge point. In the case of multi-use buildings, a different approach is taken with requirement S4. This requirement states that at least 1 in 10 parking spaces should offer EV charging for the users of those spaces. Additionally, cable routes for future connection locations must be provided for 1 in every 5 parking spaces. There are exemptions for charge point requirements in enclosed or open-sided car parks, primarily due to concerns about EV fires reported in other countries. It is important to note here that no such incidents have been reported in the UK, and this exemption serves as a precautionary measure. However, cable routes must still be provided in these instances. Lastly, discussions with the distribution network operator, or DNO, should include consideration of the total power requirement of the car park and how residents will be billed for charge point usage. There are now companies available that can manage billing on behalf of residents. So it may be slightly confusing what an associated parking space means. This term has been defined under Part S and should be fairly simple to follow. Essentially, it is a parking space that is directly linked or connected to a specific dwelling or residential unit. The diagram on the top right here essentially shows us that if a parking space is within the site boundary of a dwelling, then it can be considered associated parking, even if spaces are separated by things such as gardens. The diagram on the bottom right here shows how associated parking works for a multi-residential unit, such as a block of flats. For building 1, here we can see car park 1 and car park 3 are within its site boundary and therefore are considered associated parking. In this example, there are 14 parking spaces, meaning if there are 14 dwellings in building 1, then each space would require a charging point. However, say there are only 8 dwellings in building 1, then only 8 charging points would need to be provided, with future connection locations provided to other spaces. The flowchart to the left here just tries to simplify this further. Let's delve into the cable routes and requirements outlined in Part S. Firstly, it's crucial to choose suitable locations for electric vehicle charging points. Considering that charging inlets can be positioned differently on vehicles, some at the front and others on the side, just to clarify here, charging inlets are where the cable is connected to the car in order for it to charge. Therefore, charge point locations must be adaptable to accommodate various inlet configurations so that everyone can charge with ease. Part S states that if accessible parking spaces are provided, at least one of them must have access to a charge point or a future connection location. Just to clarify here, I've said in the past mentioned future connection locations. They refer to identified spots where an EV charge point could potentially be installed in the future to serve relevant parking spaces. Basically, Part S aims to ensure that the current infrastructure is future-proof. Thus, developers and builders are required to supply cable routes for all parking spaces capable of supporting EV charge point installations down the line. This requirement will specifically impact properties with multiple parking spaces. If you have more parking spaces than dwellings, it's necessary to ensure that all parking spaces have the cable routes to serve as these future connection locations. These future connection locations can serve multiple parking spaces as long as all spaces can be charged simultaneously at a nominal rated output of 7 kilowatts. The diagram on the right tries to explain this a little better, and it illustrates the scenario where parking spaces utilize the same charge point unit concurrently with different charging inlet configurations. And again, when installing future connection locations, all relevant guidelines must be followed. For instance, a dedicated, unobstructed route for the cables must be established, enabling easy charge point installation in the future without requiring additional construction work. So I'm going to briefly discuss some of the challenges that face installation of EV charge points and how Part S impacts them. The first issue is that of power and capacity. Traditionally, there are no minimum power limits for charge points. However, Part S now dictates a minimum 7 kilowatt nominal rated output. Most new homes have a 100 amp connection, allowing for around 23 kilowatts as standard in most cases, and therefore it is possible to accommodate this charge point within the connection. This means that when installing on a single home-by-home basis, there is often no additional electrical capacity costs due to adding a 7 kilowatt charge point. In older homes, however, this could pose an issue for those wishing to install the charge points in the future. To ensure you have sufficient capacity, though, you should always contact your DNO before installation. And in terms of new build developments, you should ensure you provide sufficient capacity to accommodate electric vehicle charging. Another crucial aspect is the safety and adequacy of the electrical connection itself. When it comes to electrical connections for charge points, it is essential to seek expert advice early on during the installation process. This ensures that you have the necessary capacity and that the installations are safe. Additionally, it is important to adhere to relevant standards, including builder regulations, to meet the required criteria. Another consideration is future-proofing your properties. The upcoming Future Home Standard in 2025 indicates a ban on new boiler installations, leading to an increased reliance on electrical heating methods like heat pumps. This may necessitate the provision of three-phase power to accommodate the higher capacity demand. Currently, residential scale charge points typically require a single-phase electricity supply. Providing three-phase supply now could be a consideration to future-proof your homes. Three-phase supply also unlocks the potential to charge at faster speeds in the future. Moving on to earthing requirements, terms like TT or PME configurations are often mentioned. These can become complex and are typically designed by lightning protection specialists. Although not delving into the intricate details here, it is crucial to seek expert advice when dealing with these specific configurations. By seeking qualified installers through competent person schemes such as NIC, EIC, you can ensure compliance with all regulations. Selecting the appropriate physical location for EV charge points presents certain challenges as well. These charge points should be installed outdoors or in outbuildings, and they can be mounted on walls or placed as standalone posts or upstands. In the accompanying image, we can observe two examples of wall-mounted units in a garage on the far right, as well as an untethered upstand unit on the left. The installation of these charge points must adhere to specific regulations, including Building Regulations Part M and the Equality Act 2010. These regulations essentially ensure that the charge points are accessible and usable by all individuals. For instance, manual controls, if provided, must be within reach of all occupants. Additionally, compliance with the IET Code of Practice is necessary. This entails avoiding trip hazards, enabling unrestricted access to the vehicle for all users, implementing appropriate protective barriers, such as on-road installations to prevent collision risks, ensuring sufficient ventilation and cooling space, positioning the charge points in well-lit areas, and keeping them remote from hazardous material storage areas. To reiterate, the wall-mounted units depicted on the right are tethered units, where the charging cable remains attached to the unit after use. The requirement for untethered units, like the upstand unit shown, is driven by the need to accommodate different inlet configurations of various vehicles, ensuring compatibility and convenience for all car owners. It is still acceptable if you're installing a charge point in your own home to install a tethered unit. Another potential challenge that EV charge points face is planning. House builders must ensure that submissions to planning authorities comply with any local policies that may be in force. In reality, however, most charge points will come under permitted development rights, provided they meet the following criteria on this slide. The main circumstance where planning permission would be required would be if a household does not have off-street parking and wishes to install an EV charge point outside their property. In these instances, all relevant rules must be followed, and further regulations are brought in, such as ensuring that you do not prohibit pedestrians walking past with trailing cables. This is why you often see charge points installed relatively close to the curb. And then lastly, EV charge point installation work comes under Part P, requiring you to have installed or registered with an approved competent person scheme. In instances where this is not the case, you would then be subject to a full building regulations application. Another aspect to consider in home charging is the integration of smart charge points, which have become the standard for installation under Part S. These intelligent charge points have the capability to automatically adjust the charging power. In theory, this allows the distribution network operator to modify your charging to align with the electricity network's requirements. However, there is a possibility that this adjustment could prevent you from charging when needed during periods of high grid demand. On the flip side, the smart functionality of these charge points enables homeowners to take advantage of multi-rate electricity tariffs. By charging their vehicles during off-peak hours, such as overnight, they can save money on the charging process. Some charge points also offer specialized controls that can be used in conjunction with solar panels and household battery storage systems. This allows users to utilize excess solar energy to charge their vehicles, rather than exporting it back to the grid for minimal financial benefit. There have been several government subsidies for the installation of charge points in the home, such as the OZEV Home Charge Scheme, which recently provided grants of up to £350 for the installation of home charge points. This provided individual households with the ability to install charge points with a subsidy. However, this scheme was replaced with the EV charge point grant in April 2022, which now prioritises the rental market. Lastly, house builders should consider consumer redress schemes like the Electric Vehicle Consumer Code. Installers registered with the EVCC must adhere to stringent regulations, including compliance with specific technical installation standards and generally providing a high-quality service. When selecting installers, it is important to take this into account, ensuring that they meet the necessary standards set out by the EVCC. So you may be wondering what exemptions are in place under Part S regulations. Well, for new builds, a cost cap has been introduced. This is a fixed limit and states that the average cost per EV charge point connection should not exceed £3,600. If it does, then you are required to install cable routes up to the limit of £3,600 per allocated parking spot. This is calculated as an average across all points, so that house builders will in essence provide as many parking spaces as financially possible within the £3,600 cap. In instances where the cost cap is exceeded, you will need to provide building control with at least 2 formal quotes to ensure that this is the case. This figure does include the costs of the actual electrical connection and not just the charge point itself. There are also exemptions dependent on certain building types when undergoing material change. For example, buildings that are listed in accordance with Section 1 of the Planning Act, or those in conservation areas designated in Section 69 of the Planning Act. If unsure, always consult your local planning authority. And here, I will not go through this, as this is simply a summary of everything discussed today, but the slides will be available for you to look through. But this is just everything discussed which is covered under Part S. In this table, we simply see the different types of buildings, what the final policy position on each building type was, and then lastly, any exemptions that apply to each building type. For example, the £3,600 cost cap I mentioned being applied for new dwellings. We haven't yet discussed the actual cost to charge an electric vehicle. Public charge points vary greatly in cost, dependent on speed, and some are even free, although you'd be lucky to find them now. At the moment, for example, 7 kilowatt connections at Tesco's cost 44 pence per kilowatt hour, whereas if you use a rapid Shell charger, these cost around 79 pence per kilowatt hour. When charging in the home, however, this is dependent on your own electricity tariffs. For private tenants on an individual household level, costs would come through as a part of your standard electricity bill. You're able to sign up for cost-saving tariffs specifically designed for EVs. For example, Octopus Energy offer an EV charging tariff which charges significantly cheaper rates to charge in periods of low demand, traditionally overnight from midnight to 6 a.m. Landlords and social housing providers can dictate how they will charge for charge point usage, if this is incorporated to normal bills or pay on use. And then lastly, schemes have been implemented to bring in electric vehicle charging in the workplace. A scheme was introduced known as the Workplace Charging Scheme, offered by the Office for Zero Emission Vehicles, which reduces the purchase and installation cost of a new workplace charging station by 75%, capped at £350 per socket. Before we end today, I just want to go over what the future may hold for electric vehicles and charge points. Firstly, we need to acknowledge that EV charge points are developing rapidly, and that 7 kilowatt units are currently termed fast, but over time, terminology adapts to what the standard is. Over time, the power of charge points is almost definitely going to increase, and public charge points are already much faster with speeds of 250 kilowatts or more, with Tesla even having them as up to 350 kilowatts. Next, we can look forward to new standards being brought in. The Office for Zero Emission Vehicles and the Department for Business, Energy and Industrial Strategy are developing new standards for energy smart appliances, including electric vehicles. The standards, known as PAS 1878 and 1879, are intended to make appliances useful to smart energy systems at the grid level to enable demand-side reduction. This essentially allows the grid to try to avoid investing in grid reinforcement to increase the capacity of the grid and instead focus on reducing peak demands. And also, standards are starting to streamline. For example, the Charging Interface Initiative, termed CHAR-IN, has been set up to promote consistency based on the CCS plug standard to avoid different plug configurations being put onto market. Dynamic load balancing is also something that is quickly being developed. This is a feature that is closely linked to smart charging technology. Currently, the majority of EV chargers offer static load balancing, which supposes manual load control. This can currently result in times where a property's electrical capacity could overload if all appliances are in use and can cause massive rises in peak demand on the grid itself. Dynamic load balancing is the perfect solution becoming available, which allows the EV charger unit with a smart sensor installed to monitor consumer consumption and adapt, setting maximum charging power at any given moment. This illustration on the slide just attempts to explain this. Essentially, it reduces the power towards a charge point when the entire capacity is at its limit. This also works in retail spaces, etc., where if all charge points are being used at the same time, it may have a lower charging speed than when only a few are in use. Essentially, this just aims to stop periods in which there is an overload on the electrical supply. Spoken briefly throughout, the prospect of bidirectional vehicle-to-grid charging is also seen as a method to manage peak electrical demand and reduce the burden off the grid in the future. Electricity demand is going to increase in the future with the increasing electrification of the UK. The general idea of vehicle-to-grid technology is that a charged car battery can send its power back to the grid during peak periods of demand. Aggregated over tens of thousands of cars, this can provide a meaningful amount of power. Consumers can benefit as well with a financial incentive applied with the grid buying electricity from your car battery at higher rates than you would be charging your car for. Studies have shown you can make as much as £1,100 per annum by being a part of vehicle-to-grid at the moment. It must be noted though, vehicle-to-grid is in its infancy, and some electric vehicle suppliers will simply not allow you to participate or they'll void your warranty. Tesla, for example, do not offer bidirectional charging. And lastly, wireless charging is already commonplace in devices such as smartphones and electric toothbrushes. But in the future, could it be that our electric vehicles are also powered wirelessly? Global technology giant Siemens have forecasted that the wireless EV charging market will be worth $2 billion by 2028. Wireless EV charging would allow consumers to escape the need for cables. The power at which these chargers would be able to hit is up for speculation, and current EVs do not have the features installed in order to do this. But this is something exciting that could feature in the future. There is even the idea of specialized lanes on our roads termed E-lanes, which would be able to charge your car whilst you drive. Although this would probably never be able to fully charge your car, this could extend range for drivers, which is one of the main concerns for new electric vehicle users, with range anxiety being put forward as one of the biggest obstacles to people purchasing electric vehicles. To round off this webinar today, my top takeaways are to understand the details surrounding Part S and what this could mean for you. Knowing that in essence, Part S is trying to increase the provision of EV charge points and understand why this is needed. To use Part S implications to think ahead and potentially future-proof now any installations you are making, such as installing three-phase provision so you don't need to retrofit later. And then that you should always find expert designers, installers, and manufacturers who follow all regulations, standards, and industry guidance when installing EV charge points. So thank you all for listening. I will now try and answer any questions that you may have.
Thank you, Sam, for the great presentation. We do have one question. It says, conversion of house to say 4 flats, no new parking spaces as part on a main road. Any requirements?
Sorry, could you repeat that one for me?
Yes, it says conversion of house to say 4 flats, no new parking spaces as parking on main road. Any requirements?
No, there wouldn't be any requirements for that, as you don't have any associated parking spaces in that remit.
Okay.
Could I come in on that, Shanika? Hello, everybody. I'm Neil Cutland. I'm Sarva's consultancy director. Sam's in my team. I was recently at a conference about the current state of the art and the future of EV technology. And one of the things that I was really keen on mugging up on was not so much the types of cars and the types of actual charge points and the technology, so much as the practical implications. Because for me, there's no point us having policies nationally or locally that are not pragmatically possible to implement. So one of the things that's been preoccupying me for a long time has been off-plot parking or on-street parking, if you prefer, and in particular in terrace streets where you can't necessarily guarantee to park outside your own house a lot of the time. And I was quite comforted at this exhibition just last week to see a lot of companies are selling solutions now. So, for example, to run your own charge cable from your property across the pavement to your car, if you are lucky enough to park outside your own house. There are a number of people selling prefabricated trenches, but small ones like slots almost that you drill into the pavement and you run your cable through that. And then there's a lockable metal cover over it to stop people putting their stiletto heels down it or whatever. There's also a number of companies selling very low profile soft plastic covers, the kind of trip hazard covers that you put over cables. There's some very, very low profile ones. But I guess certainly the drilled in trench solution would need local authorities to give permission or to do it themselves, because you'd be interfering with the public highway. But that's one way you can trail a cable from your own charge point to your vehicle across the pavement, or several different ways. The other thing that intrigues me is the companies that are doing light lamppost conversions. So especially in London, I think there's a lot of these springing up where the guy I was talking to at the conference said it takes about 90 minutes to install the conversion kit, and you essentially end up with an EV socket on a lamppost. Which again would have to be done by local undertakers of one sort or another. It wouldn't be something you could do as a private individual. And then to answer the question about when those lampposts are on the backside of the pavement, so in other words, they're not up against the curb, which is pretty common. Well, those same people have a solution where they install a little bollard. It looks like a traditional black upright bollard with the charge point in it, and you run the cable from the lamppost to that under the pavement, and you put that obviously on the curb. So I was heartened to see that there are a lot of companies aware of this and trying to address this, but it is a very important issue.
Thank you.
Just to answer Sean Williams's question there, does Part S apply to material change of use to new holiday lets? This would be factored into, are you changing from commercial to residential? If it's residential to residential, then it's fine. If you are changing from an office, say, to a holiday let, then yeah, it would apply.
Do you have any information for electrical wheelchairs that need charging with the home by any chance?
I have not come across that, no. I apologise for that. No, by any chance. Yeah.
Okay, no problem. Are there charge points secured to prevent unauthorised charging, particularly on multiple parking spaces?
So most charge points require smart charging capabilities now. So you have to have an app to connect to anyway. The only one I know that actually just charges straight away without charging is Pod Point, where you can get a 15-minute grace period at the moment. So in terms of billing, you're not going to get anyone just securing up and using those charge points, which is going to cost you money. There are schemes being put forward where people can rent out their charge points if they have one at the home. These are very much in their infancy, but it's still determined how you can charge for them. But they are secure. You wouldn't have someone just being able to come onto your property and just plug their own car in unless you were to give them permission.
Is there currently any guidance or evidence that can be used by an approval body to verify a quote to demonstrate the cost of installing electrical charge point is accurate rather than relying on the quotation?
Well, as said, the RAC estimate that the average cost of installation is around £800. I know that you can buy these units for £300 to £400 just on their own and then get someone to install them, but the rough costing is around £800 on that.
Okay. Is there potential for theft or charge cables? Sorry.
When your charge cable is plugged into a charging point, it's pretty much impossible to get it out unless your vehicle has stopped charging. So in terms of theft, no, it'd just be a matter of if they stole it from the back of your car, etc. But it's not when in use. So your cable will be absolutely fine when you're using it.
In your view, for a new build non-residential building where there are already 10 plus parking spaces as existing, is EV charging required in accordance with Part S, or does the 10 plus parking spaces need to be new spaces associated with the new build? And that's from Paul Moore.
Non-residential building, already 10 plus parking. It's only if it's a new development that it would be required. And also for non-residential buildings, it's a 1 in 10, it's not all 10. So it's more to provide the cable routes at the moment to ensure that EV charging points can be installed in the future. So in essence to that, yes, it's the 10 plus parking spaces need to be new spaces associated with the new build, not that they were existing.
Does Part S apply to Wales?
Yes, it does. Yeah.
And the last one, I'm buying into going all electric, but the infrastructure from the national grid is years away from being able to supply the electricity required for the move from combustion vehicles to all electric. Also, when all of us move to electric, there will be no cheap tariffs for overnight charging, as everyone will be doing this to enable their next daily commute. More emphasis should be given to electrical generation at home, e.g. solar to battery storage. And that was just a comment.
Yeah, I completely agree with that. It's if everyone was to move to electric vehicles overnight, there would probably be quite a dramatic shift. But it's all about slow integration. That's why these targets have been set in, and that's why the Part S regulations are so vital to come into force now. If we need many more public charge points. I don't know if anyone here has had the issue of having to wait at charge points, but I've had it quite a few times with my car where I've had to just wait for up to 30 minutes for a charge point to be free for me to use it. So there are still issues that are surrounding it, but hopefully Part S is in place now to try and increase the uptake in electric charging points around and just have more charging points for people to be able to use.
Thank you, Sam. I would like to thank everyone who has joined us this morning. Just to remind you that this session has been recorded and will be uploaded to our YouTube channel soon, which we can share with your colleagues. If you have any feedback on this webinar or any topic suggestions you would like to see us cover, please do get in touch. With that, I'll wrap up and thank you again for your time, and we'll hopefully see you all next month. So thank you, Sam, for the great presentation.
Thank you very much. Cheers, guys.